is the first slide of quite a few. And I made a list here of things that I think are going to be advantages for some of the new vertical takeoff and landing aircraft. And most of them are going to be electric powered. Some might be hybrid, and but faster, quieter, more energy efficient, safer, less maintenance, no fossil fuel. So I'll try to make a case for this. And at the end, we'll go into a little more detail about those. So going on, there's an organization in California that makes its business of keeping track of the progress of the things that are called eVTOLs, electric vertical takeoff and landing aircraft. Some of them are for passengers, some of them are for cargo, some of them are pretty big, some of them are smaller, but they keep an updated spreadsheet. I presented this last year, by the way, and this is an updated spreadsheet from the same source. And you can find it yourself. At the bottom on the slide, there's the website, and you could, because the spreadsheets are very busy to take in all of the info. Now, what they're saying is they're trying to give a ranking or rating tool based on the likelihood that one of these companies will certify the aircraft into service and produce it in thousands of units per year. That would be quite a bit more than anybody can do right now with those. So here's the first of two spreadsheets from that source. And as I said, it's pretty busy. You can all move your chairs way up to the front if you want to really read it. But on the left is the name of the company. And the next column over, ARI, is what they call Advanced Mobility Readiness Index. And you see there are four that are kind of tied at the top with an index rating of 8.0. One is from Germany, one is from China, one is from California, and one is from New York. Pretty close to us, actually. So can you all read the names of those companies from where you're sitting? Well enough or not? Okay. Anyway, you'll notice that there is stock trading on many of these companies. For example, the second one down, EHang, you can buy shares of stock in the company. NASDAQ, symbol is EH. It's pretty volatile, but you can do that. The next one down is by far the largest funded of these companies. They've got $2 billion of funding at this point, and that's about twice as much as anybody else. That's Joby, and most of these are going to be used for air taxi operations, kind of like a limousine in the sky. If you want to get from Manhattan to JFK Airport and you're really in a hurry, this will be the fastest way to get there from downtown Manhattan to any of the airports around New York. And that's seriously what they're going to have in about 1 or 2 years from now.
What is EIS?
Say again?
EIS.
Oh, entry into service. Okay. That's when they're going to actually be flying and commercial passengers, etc.
You still have to get somewhere in Manhattan to the heliport.
Say again?
You still have to get from somewhere in Manhattan.
Yeah, take the subway. Not a big deal. I'd like to establish a rule here, if I could. I'd like to take questions from everybody, but if you've already asked one question, could you wait until the very end to ask your second question? Does that seem fair? Okay, we'll try to do it that way. I've been in some talks where one person asks questions over and over and over again, and the speaker gets only halfway through the talk. Seriously. So I've got a lot of stuff here to talk about. But you can look at the column headings here. The third column over is funding, how many billions of dollars some of these companies have received from real world investors. And of course, Joby is on the New York Stock Exchange. You can buy shares of stock. JOBY is the symbol. Vehicle type, multi-copter, vectored thrust. There's a significant difference there. Some of these aircraft have wings. So with wings, they can convert over into a horizontal flight, just like a conventional airplane. That's pretty fast. That's faster than a helicopter. The ones they call, well, like EHang, multi-copter lift and cruise, that does not have wings. So that's going to be going quite a bit slower. But there'll be a use for it as well. Anyway, that's vehicle type. Propulsion, almost all electric. But down near the bottom, there's one that's a hybrid. And on the next screen, actually, there are 28 companies listed at the website. These are the first 14. The next 14 are on the very next slide. And I'm going to go into detail only on about the top 9 of these, which are the most likely ones to come into widespread use. Operation, piloted or autonomous. Which would you like? Do you want a pilot, or do you trust the computer and somebody on the ground to get you there safely? There's arguments on both sides of that issue. Boeing puts all of its money on the autonomous version of this. Boeing is not putting any money at all into a piloted aircraft for this purpose. That's the Whisk, which is 1, 2, 3, 4, 5, 6. The 6th one down from the top. And then we have a vehicle name. Most of these do have specific names or model numbers. And the next column is the very first flight. Now, the very first flight is kind of ambiguous because they have, for example, Volocopter, German company. They've actually been flying prototypes for about 15 years. About 2010 or 11, they had a very crude prototype flying. So take it with a grain of salt.
Which one is that?
That one is Volocopter. Now, Volocopter has 2 models listed on this spreadsheet. One they call Volo City and the other Volo Region. I'll show you pictures of both of those. So anyway, you can see, if you want to, all of the other data for these 14. Now, here is the second 14. One of these is actually hydrogen powered. The second one down on this page, no, the third one down, Alakai, that's presumably going to be powered with a hydrogen fuel cell. But almost all the others are not hydrogen. Some are hybrid, electric and fossil fuel. So moving along, I'm going to show you pictures and some data for at least the first 9 and a few others from the spreadsheet. So this one is, it might be the one that had its prototype flying the very longest. And it's a German company. They got 18 electric motors and propellers to lift it up and carry it whichever way they want to go. Maximum speed, 62 miles per hour, range 17 miles. It can carry 2 people. One is going to be a passenger, one is going to be the pilot, or they call it the crew. And the name of the craft is Volo City. Now, there's a company in Texas that you might call a copycat. They are developing, or have developed, a single passenger, smaller version, essentially, of what Volocopter in Germany has done. 18 motors and propellers on the top. The company is Lyft, and the product is Hexa. And you notice the black bulbous things at the bottom, those are floats. So this aircraft can land and take off from water. Make sure the waves aren't too high. Could be a problem. Oh, by the way, this aircraft, they're going to be taking around the country this year. And if you watch your news, they're probably going to have a stop around New York City, and you can drive over there and take a ride in this aircraft. I believe that's the plan.
It only seats one person.
Hey, say again?
It only seats one person. It looks like in the picture.
That's true. One person. There's going to be some amount of training you have to do before they'll let you take it up. But that is the plan for it. So we'll see how that works. Okay, this is the second version follow-on from the Volo City aircraft that had the 18 motors and propellers on the top. In this case, they've got wings. So it'll fly quite a bit faster, and it might take as many as three passengers and a crew. So at the maximum, oh no, wait a minute, this is autopilot. I didn't remember that. Crew, none, autopilot. Capacity, 2 to 3 passengers. So they've got 6 vertical motors and propellers to lift it up and hover. Once they're up high enough, they turn those 2 fan jets on near the back of the aircraft, and they fly off at 160 miles per hour horizontally to wherever they want to go. And then they go back to a hovering mode to slowly come back down again. So this is kind of a typical eVTOL design. So they got both maximum speed and cruise speed listed here. Okay, moving along. This is the one and only aircraft that is commercially flying right now, fully approved, but only in China. So China is ahead of us by about a year in actual commercial use of these kind of aircraft. And as I mentioned earlier, you could buy shares of stock in this company. Some of my friends say they'll never get near this thing because it's too dangerous. If those, yeah, so we'll see. Now the next slide I think has some numbers for this aircraft. So crew, none, self-piloted or autonomous, you might say. Capacity, 2 people. 16 propellers and motors. Maximum speed 99 miles per hour, cruise speed 81 miles per hour. And they have a newer version listed at the bottom, 216S, and expanded range up to 20 miles. So they're doing it. They have this flying regularly, but only in China. This is probably the #1 likely large producer, well, the first #1 likely large producer of eVTOLs in this country. And because they're the highest funded company, basically. And they've had good luck, pretty good luck with their test flights so far. So they've got 6 motors and propellers, and each of those motors and propellers can be rotated 90 degrees. Have any of you heard of the V-22 Osprey? Okay, quite a few of you have. This is similar, but the Osprey has 2, this one has 6. So I believe the way they've designed it is if one of these 6 fails, I think the other 5 will still allow it to fly safely down to the Earth. But when you get larger numbers of motors and propellers, that's a redundancy feature, and it's safer that way. Okay, here are some numbers for the Joby aircraft. Notice 200 miles per hour. That's faster than most common helicopters. 4 passengers and a pilot, travels 150 miles, etc. I guess you can read all this stuff. Now, notice this, near silent in flight. The aircraft is designed to be 100 times quieter during takeoff and landing than a helicopter. The reason you don't see many helicopters around cities or anywhere these days, well, especially around cities, is because of the noise and the danger and the maintenance and fuel they require. All of those things are so much a negative that the prospects for helicopters doing tourism and the back and forth to an airport is very minimal, and that's reasonable. So quiet is good. So moving along. Okay, this is the next airplane on the list. This is the one in New York. I'm just going down this list. Volocopter, EHang, Joby, Beta Technologies. Actually, I said New York. They had one of their facilities along Lake Champlain in New York, but their headquarters, I believe, is Burlington, Vermont. So not too far away. Now, the use case, cargo and air taxi. Now, interestingly, you notice also in the vehicle, they have 2 types of vehicles that they're going to be producing, that they are producing now and are testing now. One is not a VTOL, it's a conventional takeoff and landing. I'll go back to that. Okay, so these are the 2 versions that they're intending to provide over a long term, I guess. But the one on the left is actually the first one they want to have fully certified and flying commercially. And it'll be flying cargo and passengers only horizontal. It needs an airport. That's where the word conventional C comes in. Actually, to be complete, these should be called E-CTOL and E-VTOL. So you notice it has a single pusher propeller at the back, but it flies fast enough that way to satisfy most people. They do not have 90-degree tilt angles on their motors and propellers. They're fixed in a vertical rotation axis. So just like a quadcopter, it's got 4 pretty big motors and propellers at the top. I'm talking about the one on the right, the VTOL. So this design is pretty well streamlined, flies pretty fast. Here's some numbers for it. Okay. You can read this yourself, I guess. They have a range of up to 250 nautical miles, which is kind of better than most of their competitors. They've got a 50-foot wing, so they could actually glide this plane to an airport if they had to. So maximum range of 250 nautical miles, weight of 6,000 pounds, cruise speed 170 miles per hour. Those are pretty good numbers compared to their competitors. So I think they'll be a success.
What's takeoff role on the convention?
Say that again?
Don't worry about it, I'll look it up.
Okay. So the next one down on the list is a company in California. They're a pretty much direct competitor to Joby, also in California, but they have a different approach to their propellers and motors. Instead of 6 like Joby has, they've got 12, 6 in front and 6 in the back. So they all 12 of those will lift the aircraft up, straight up, and hover. Once they get up there, they're going to do a 90-degree tilt on the front 6, so that they can, and they've got a wing or wings, so they can they can fly pretty fast horizontally. You notice the word United there. United Airlines is a big investor and perhaps partner with this company. And the other major airlines, American, Delta, etc., they are also partnering with many of these companies. So if you buy an airline ticket on United and you happen to be in the middle of a big city, United might have its own eVTOL, which will take you right to the larger plane at the airport to fly off in.
And when it goes into cruise mode, do the rear motors turn off?
In this case, I believe what they're going to do is have the, by the way, that's your last question until the end, right?
Okay.
I believe that what they're going to have is the rear propellers will line up with the direction of flight so as to minimize the drag. And that's probably all they're going to do to take care of that issue. So the next slide has some numbers for this. Passenger capacity 4, range 100 miles, cruise speed 150 miles per hour, maximum altitude 2,000 feet. So anyway, you can maximum takeoff weight 7,000 pounds, wingspan 48 feet. At the bottom, there's a little bit of anecdotal information about the aircraft. So moving along. Okay, this is the competitor from Boeing, and it's one of the few leaders that's intended to be only autonomous, no pilot. The people at Boeing felt that that was their optimum investment. Time will tell if they're right or not. But you notice the propellers and arrangement on the front and the back of the wing is very similar to Archer, very similar to this. And actually, there were some lawsuits going back and forth as to who cheated and who stole the patent rights from which other company. And they finally settled it somehow or other. I'm not sure how the settlement was done, but there is indeed quite a bit of similarity. 6 in the front of the wing and 6 in the back, same as for Boeing. This may not be the most recent version of this aircraft. They have the right to change the design in some small ways from 1 month to another. So, but you can check that out. Just go to the website and see for yourself. Okay, this one is called Eve, EVE, and it's a branch of a large company called Embraer. Embraer makes large airliners, been around a long time, but this is the only one in Brazil. 4-passenger. This is an artist's conception, but they are very serious about doing this, and I'm pretty sure it'll succeed. In this case, instead of 6 in the front and 6 in the back, they only have 4 in the front and 4 in the back of the wing. And then you've got a pusher propeller, which you can barely see at the rear of the plane to have a pretty high speed flight horizontally. Okay, this is another entry from China. And the Geely company, is it Geely or Geely? I don't know. Anyway, that's a pretty big automotive company in China, and they want to get into the aircraft business as well. So this is their entry for that. I think this can take either 4 or 6 passengers with at least 1 pilot. For these, if you want to see the details, of course, you can just go to the website for each of these companies, and you can get all that. So this is the only one right now from England. It's called Vertical Aerospace. And the model, they say it's the VA-X4. This is the interior cutaway view. So you see they have 4 passengers and 1 pilot in the front. So again, they're using the 90-degree tilt angle for the front motors and propellers. Okay, this is another German company with a much different design. The name of it is Lilium, and you can buy shares of stock in this company also. What they're doing is they're developing powerful fan jets, small but powerful. And they've got 36 of those lined up on a large wing near the rear and a canard type wing, smaller, up near the nose. So if you count each of those ducted fans, you'll count 36. Now, I believe this aircraft will not be able to hover indefinitely because those motors and fans are so small that they're going to have so much power coming into them that I believe they will probably overheat within a certain time period. But that's okay because once they get up high enough, they're going to rotate 90 degrees and fly off horizontally. So in that case, they need much less power from each of those ducted fans to carry the aircraft to where it needs to go. But again, time will tell which of these fully succeed and which do not. Here are some numbers for the Lilium. They call it a jet, but it's not a turbojet. These are electric motors and turbines, or electric motors and turbines inside of a small ducted enclosure, duct type enclosure. Now they've got a pretty big interior. They've got 7 seats, seven seats for passengers and 1 pilot. So, oh wait a minute, I'm wrong. 6 passengers and 1 pilot. 7 people in the airplane. 155 miles per hour. They can fly for 1 hour, 155 miles. They can go up as high as 10,000 feet. Maximum takeoff weight, 7,000 pounds. As I said, 36 motors and propellers. Ducted electric vectored thrust fans is the official terminology. Okay. Oh, notice at the very bottom, 6 to 7 times quieter than a helicopter at takeoff. That's a selling point of the ducted fan idea. Here's something quite a bit different. And this is not a vertical takeoff aircraft. However, they only need 300 feet runway length to take off. And this uses a technology which is called blown wings, B-L-O-W-N. They're blowing air across the wings. And as anybody who flies an airplane knows, when you have high-speed air coming across the wings of an aircraft, you've got pretty good lift. And so basically, even though this plane is sitting still on the runway, when they rev up their motors, they've got so much lift that it's almost going to take off if they don't have it tied down anyway. Not quite, but 300-foot runway for this kind of a large airplane is pretty unusual. Nine passengers, 200 miles per hour, 500 miles. So,
one question.
Sure.
This is probably one of the most promising aircraft. It doesn't quite take off vertically, but they can put that 300-foot landing area. The takeoff roll is estimated to be 150 feet, so that you'll be clearing an obstacle by the time you hit there. And the thing that's really interesting, well, there are two other points that I'll shut up, is an 80% steel model pilot was test flown this November. And it also verified operation for 2 things. One of the reasons it has such good mileage, there are 2 reasons. One is it doesn't waste a lot of power on vertical takeoff, which is incredibly, it's actually conventional airplane, which means it's horsepower for maintaining lift, required to maintain lift as much. The second thing is that this is what they call a hybrid aircraft. They have a small turbine generator, so depending on the mission, the batteries will supply anywhere between 50 and 100% of the power required for the flight itself. And when they need to extend the range, they can turn it on. I'm still trying to, I'm doing a story on this, and I'm still trying to determine whether they use the turbine generator on takeoff for, to augment the power. But it's probably one of the best approaches. As long as you don't need absolute vertical flight, it's probably the most efficient.
Yeah, yeah, I think this has a lot of promise. Thank you for the details on that.
No, I'm done.
That was a very positive addition. Thank you very much. A couple of other little things about this aircraft. It's got big flaps. So the motors and propellers are located a little bit down from the center line of the wings because they want to maximize the airflow right on those flaps to give the high lift. So it's a good design. Another anecdote for this, there's a guy named John Langford, who is the president of this company, founder of it. And he also founded the company called Aurora Flight Sciences that evolved into the Whisk aircraft, now owned by Boeing. So he's kind of a pioneer. He's the individual behind two of the aircraft that I'm talking about here today so far. So this aircraft is on the list. If I go back, you'll see it. Electra, it's near the bottom. So I guess the people that generated the spreadsheet felt that there were other companies more likely to succeed than Electra, but you can see it there, fourth from the bottom.
They have 2,000 orders.
Yeah, that's right.
And
so
one regional air carrier just put an order for 150.
Okay.
That is expected. They expect that sometime beginning in late 25.
And you're writing an article about it?
I'm writing. Well, I wrote a short article about Electra, and well, it was actually about two acquisitions by this one large regional air carrier, also doing electric aircraft based on a modified Cessna. But then I'm in the researching feature on hybrid electric aircraft.
Oh, good. Good.
Sorry,
Which publication will your articles come out in?
Design.
Pardon?
Electronic
Yeah.
Design
Okay, that's great. I'll have to watch for those. Okay, thanks again. So you can see a few other little things here about the Electra if you can read the fine print, like it hybrid piloted. First flight was last year, but these big planes are a little longer to put into full service. So they're estimating 4 years from now, 2028, to get commercial service.
That's right. I'm sorry. The FAA certification didn't take a while.
Yeah.
But I think they want to start taking delivery of prototypes for evaluation soon.
Okay. All right. So the next aircraft here is actually not on the list. However, it's pretty interesting. I believe it's headquartered in Long Beach, California. That is the development of it. And the name of it is Otis, O-D-Y-S. It is a hybrid. It has 9 passengers, 2 pilots, but look at the speed, 345 miles per hour. That's way beyond helicopters. 200 miles range. Now, it'll have a gas turbine generator. And so with the generator, it can go up to 750 miles. So it can be either all electric or hybrid, I guess. Now, looking at this aircraft, it's hard to imagine how it could take off vertically. You would think that if this aircraft was sitting on a slippery runway, and they rev up those engines, there's going to be a strong force pulling it forward. However, I think they have some tricks up their sleeves as to how they can make it actually take off vertically. We can go into more detail on that if anybody wants to, but they claim that. So this is one of the highest speed of the aircraft that I'm talking about here today. Now, suppose that 345 miles per hour is still too slow for you. You want to go 500 miles per hour, not 400, not 300. You want to go 500 miles per hour. I think there's a way to do that. And it's still in the idea stage. This is what I would propose might be done to get up to maybe 500 miles per hour with a real aircraft with passengers. So this view or sketch, drawing, whatever you want to call it, was taken from a real aircraft with wings. And I just, with graphics software, I removed the wings. But I did add 4 things that are called stabilators. A stabilator is a combination horizontal stabilizer and elevator. It's just a little thin paddle type thing that you can rotate about the horizontal axis. So there are 4 of them showing here. Those 4 will give good control over pitch and roll for the aircraft. The rudder at the back will take care of the yaw control. So even without any swash plates. Now, do most of you know what a swash plate is? Anybody know? I hear a couple of people. Anyway, a swash plate is the mechanism that allows a conventional helicopter to function. It's a pretty complex mechanism, but it's been developed over many, many decades and a lot of moving parts. It controls the collective pitch of all of the rotor blades, and it also controls the pitch in what's called a cyclic control, so that you can have the aircraft tilt forward, tilt sideways, tilt backwards, whatever you want to do. So the aircraft can tilt to, if you want to go forward, you tilt the nose down. If you want to slow down and go backwards, you tilt the nose up, etc. So that's a cyclic control. And then it also has a collective control. But this aircraft can avoid all of that. What it does have is at the center, at the hub locations of those 2 rotors, it's got a mechanism which can rotate each of those blades individually about its axis. So when you want to take off, you take off vertically. Oh, so also inside of this plane, my assumption is that it would be electric motor and battery power, just like a Tesla automobile. And it would be precisely controlled so that you go up pretty high, thousands of feet, straight up. Once you're up there, you set the aircraft into a glide going kind of down at an angle toward the earth. And while you're in that glide, you convert the 4 blades into wings by rotating 2 of them 180 degrees and then putting them in a horizontal position so that you can use them as wings flying horizontally. This idea was patented in I've seen it in at least 3 different patents. Oh, by the way, somebody remind me when we're near the end. How much time do I have?
About 15 minutes.
About 15? I'll try to wrap it up in at least 10. Okay. So anyway, I think this plane, like a Learjet, can fly over. There were many models of Learjets. Some of them flew well over 500 miles per hour. So this aircraft can have actually smaller area wings because it does not need to take off from a runway. if you have a Learjet or any other similar aircraft, you better have wings big enough to get you high speed down the runway and over the trees. And so this aircraft does not have that constraint. So that's why I have some optimism for it. But it needs a lot of work to prove it out. And maybe I'm missing something. But if any of you want to discuss it with me, I'd be happy to do that. Now, I'm assuming to get 500 miles per hour, these would be conventional turbojets. But they're noisy. So suppose I don't need to go quite that fast, but I want to be quiet. Here's an option for that. There's a pretty new company called Whisper. Whisper.aero is the website listed at the bottom here. Just like Lilium, they have some proprietary ducted fan propulsors. And here are two of them listed at the top. Notice how big they are. The one on the left is only 6.3 inches in diameter. The one on the right is only 9.8 inches fan diameter. Yeah, fan diameter. So I guess the outer diameter is a little bit bigger than that. But they're not nearly as much thrust as a small turbojet would be, but nevertheless, they could propel an aircraft. Now, look at the second line down in the text at the bottom. 100 times quieter than similar engines and higher efficiency by 20% compared to similar ducted fans, I guess they're saying. So one of their tricks is to have such a large number of blades and at the rotation rate of those blades, the blade passage frequency is above 16,000 hertz, which is out of the range of most human hearing. So that's what makes it quiet. It's making noise and your dog might not like to be around it, but you might not hear it. I'm sure I would not hear it. So now suppose we have some high power versions of this ducted fan and we put them here. Instead of the turbojets, we put one or two of the Whisper jets near the back of this aircraft. And also we could use 4 more of those Whisper jets at the tips of each of those blades. So now we have what's called a tip jet propulsion method for this aircraft. And then once it's flying horizontally, we have 6 Whisper jets pulling it horizontally. So if we have only 70 pounds thrust for one of those Whisper jets, 6 times 70 is about 400 pounds of thrust. I guess we could guess how fast it might go, but I would guess pretty fast. But this needs a lot of work to prove out. I'd be happy to discuss it with anyone who cares. Okay, this is not electric at all. This one happens to be turboprop engines, but it is a VTOL. My talk is about VTOLs in general. So this one is kind of similar to the V-22 Osprey, but instead of rotating only the motors and propellers, they're going to rotate the whole wings on this aircraft, 90 degrees. So this shows it flying horizontally, cruise speed 486 miles per hour, range 1,000 miles, 7 passengers plus a pilot. There's the website. They're headquartered in Massachusetts. And notice this, 11,000 pounds aircraft, they've got a ballistic parachute. If something goes wrong in a V-22, I don't think it has a parachute. Bob, does it? No. And occasionally some things do go wrong in those Ospreys. This one's got a parachute. We have a man in the audience who knows directly about all of this. So anyway, there are others of the small airplanes that will have parachutes as well. But a lot of companies feel that they have so much redundancy in their design that they don't even bother or have the expense of a parachute to give one extra step of safety. So
save one life.
Yeah, I don't know, but anyway, this is my last slide. Am I out of time now or not quite?
7 minutes.
7 minutes, okay.
How did that last aircraft, how does it achieve vertical takeoff?
They rotate the wings and the propellers and the motor 90 degrees. It goes straight up then. The rotation axis for both of the motor and propellers is straight up. Pulls it straight up. Once they're up high enough, they rotate them and they go horizontally. Right? Okay, so I'm just repeating here what was on the first slide. I think I've probably shown well enough that some of these aircraft will be faster than the most common helicopters. Also, I have a little bit of a short list here as a comparison, which I'll bring out. One of the popular commercial small helicopter brands is called Robinson, and they have 3 different sizes, models, R22, R44, R66. And the smallest one, R22, has a cruise speed of 110 miles per hour and a absolute maximum speed of 117 miles per hour. Way slower than the 200 miles per hour Joby. The R44 from Robinson, cruise speed 125 miles per hour, absolute maximum 150 miles per hour. The larger one, the R66, 130 miles per hour cruise, 160 miles per hour maximum. So they're all below 200. Bell has a 505 helicopter, and that has a cruise speed of 144 miles per hour. So that's pretty typical, between 100 and 200 miles per hour for helicopters. Is that about right, Bob? Yeah, I think it is.
That is not my minute.
Say what?
That's not my comment time.
Okay, so now quieter. I think I've already made the case for quieter. Even 100 times quieter, they claim. So more energy efficient. Electric motors can be 90 to 98% efficient, believe it or not. Gasoline or fossil fuel motors and propulsion units are lucky to be between 25 and 30% efficient. So we have about a factor of 3 improved efficiency when you have electric motors. Okay, safer. Think about safety. If you have a helicopter that has a big rotor on the top and a small rotor on the back, it'll fly. Now many of the aircraft that we're talking about here, this one on the right, it also has a small propeller near the back, and it's got, instead of only 1 rotor at the top, it's got 4, but it does the same function. It pushes air down as fast as it can to allow the aircraft to go straight up and hover. So basically there's some similarity between helicopter design and this design. Large propulsion to push air down to lift it up, and then a small propeller at the back. So you'd say, well, the reliability, safety is about the same on those, right? No, not right. With a helicopter, if that tail rotor fails, the helicopter is going to start to spin. And if the pilot is not alert to take care of things, it's going to end badly. If the main rotor fails, it'll drop like a rock. Now this aircraft, not the same thing. In this aircraft, if either of the vertical axis propulsion fails or the tail pusher propeller fails, no problem. If the pusher propeller fails, it still flies just like a regular helicopter. It can come right down slowly, land safely, no problem. If the vertical propulsion system fails completely, no problem. The pusher propeller will fly the plane to the nearest airport, land safely. No problem. So that's a much different case than helicopters in terms of safety. And if all else fails, they could put a ballistic parachute in this aircraft as well. So instead of having only one way to get down safely with a conventional airplane, usually, unless it's a Cirrus, this airplane has possibly 3 ways to get down to the ground safely. So I think I made the case for safety. What else is on the list here? Oops. Okay, yeah, less maintenance. Think about the design from Volocopter. It's got 18 motors and propellers. So it's got a total of 18 moving parts. How much maintenance do you think that needs for electric motor and propeller? It's like an electric fan sitting in your living room. How much maintenance have you ever had to do on your electric fan in your living room? Probably nothing. If 1 or 2 or 3 of those Volocopter motors and propellers fails, you might not even notice it. It's got 15 others that keep it flying. No problem at all. A helicopter is not in that category at all. And so I think I made that case. No fossil fuel. If it's all electric and you got plenty of wind power and solar power, no fossil fuel. Anyway, that's my termination point. So anything else anybody would like to ask or say? Go ahead, Steve.
Yeah. You have any thoughts about how expensive travel, is going to be for the passengers? Because it seems like most of these only handle a very small number.
That's right.
Of passengers. So
yeah.
Does that mean that they're going to be pretty expensive?
Well, if you look at the Joby website, I think they're saying that it'll be within about a factor of 2 of if you take a taxi or limousine. Yeah, it's in the ballpark. But they have very little maintenance, very little fuel. That is electricity. Electric cars compared to gasoline cars, less. So, but those numbers are not set in stone yet. Yeah, Frank.
Just a couple quick ones.
Yeah.
I'm just going to be super quick because I know everyone's on the clock. Your example of an air vehicle, 400 pounds of thrust. Aircraft that size, you're not even going to be able to taxi at 400 pounds.
Oh, we don't need to taxi. No taxi. Well, how much thrust does a glider, electric powered glider, have?
If you look at, it's probably a couple hundred pounds of thrust.
Yeah.
When you think of the engine.
So,
but
yeah,
that's super. The other thing is in terminal areas, airplanes that are all gathering, all the slots in all major airports are also competitively bid for. They're all full.
Oh, no, these aircraft are not going to compete that way at all. Well, these are going to have their own things called vertiports. It's like a heliport. It's like a expanded heliport. Yeah, so they're already working on that issue, but the name is vertiport. Yeah.
And the last thing is, how would you integrate autonomous flight with ATC netting?
That's going to be a question. I'm not sure about that. Time will tell how that gets integrated. Yes.
Okay.